Hello again, friends. And I'm excited to start this video. This is actually definitely not the first time that I am trying to shoot this video. I made a number of changes to what I should talk about, and so I kind of realized that in order to properly do this series on reflex-dom as well as obelisk, it's important for me to kind of sell you on why this is worth learning over JavaScript. And so, definitely it's quite like the analogy of how snowboarding is a lot. Snowboarding is a lot harder to learn but easier to master than skiing, where skiing is easier to start but difficult to master. Um, it is definitely an investment in learning reflex, but I think it's definitely a worthy investment, and we'll see why. And so, in order to see why, we kind of need to understand the relationship between the two options of reflex-dom and JavaScript. And so, in terms of JavaScript, since there's so many different frameworks and options that are available, I'm most specifically talking about vanilla JavaScript. And of course, that's not an actual framework, it just literally means um, plain and simple JavaScript without any sort of framework. And the reason for this is that um, it really just fully shows the complexity that evolves with building a front end web application through JavaScript. And of course, this complexity will, in a sense, always be there, but a lot of this is really handled by Reflex. And ultimately, what Reflex does for us is create a a very simple interface to think about complex applications. Um, and so, in understanding the reason for that, or the kind of reasoning for why that is, or how that comes to be, it's important to understand FRP. And before we can understand FRP, we need to understand, or just kind of realize the complexity of a JavaScript application. And so let's start by looking at a JavaScript application. Um, what is one that could be, maybe YouTube might be a good way to look, or a good thing to look at, as well as I have an old project which I did all through vanilla JavaScript, which currently I plan to share the source code with. I don't see any reason why not to. It's kind of just an old, crappy project, but built a WebRTC application, which makes the work of what I was doing in the JavaScript application a little bit more complex. I think if let's say we had just a simple one page web app where it's just static HTML, Reflex would definitely be overkill, because what Reflex, at the end of the day does is help us to simplify the event structure that we have to deal with in JavaScript applications and complex applications like video games. You can use FRP for robotics and simulation. But anyways, the point of this video is to talk about the DOM and the document object model, or if you will, even the browser object model, but more so the document object model. Um, and so if we look at uh, YouTube as an example, one example just kind of clicking around that I think is an easy one to bite on is these buttons here. So by selecting one of these buttons, some event is firing that tells the DOM to update itself, and that results in a new document with all these new videos, all these new links that I can click on. A little bit more complicated of one might be actually going to the videos and the actual you could in theory model the event of data reaching from the YouTube server, or video data reaching from the YouTube server to our web browser and being displayed as an event. Um, and I'm obviously I'm not sure how they actually implement YouTube videos. I'm not aware of that. Never looked into that. Don't think it's even open source or whatever. But nor do I care. But yeah. So anyways, the one example that I can give is this is me, by the way. This little project I built here. So this is just using the WebRTC media API. And so I have, this little uh, simple DOM here. Obviously not a lot of CSS, but not about CSS here. And so this is going to change if I click on start recording, as well as we're going to have another event fire, which will actually start the media recorder API. So if I do that, voila, we update the DOM, and now it is recording, and that data is being saved to just an array, which is eventually going to then be chunked up and sent to a server. And so if I do that, not recording, video created below. What is this? I have an updated document that is showing a video element, which I can pull up here. Right. So if I do that, ooh, did not want to hear that. So yeah, so I have some event that is happening based on a button being clicked that runs some JavaScript and produces a new DOM. However, let's say I have multiple things that are going to output videos, or we start to have some intersection of events going on. Maybe for example, I believe that this actually just destroys the video. I think this just literally reloads the page, which is like absolute crap. Not the best way of doing things, but literally I pumped this out in a couple days. So yeah, but so this will refresh the page. But let's say I did this properly. This might, if I say start recording again, stop recording, it should, in theory, update this video element with a new array of video bytes. And so, that could actually get quite complicated, or sorry, even further, we could have a more complicated situation, which is that this video here just gets replaced by the video that was created, and then we have to switch back and forth from watching to to recording, and so that makes it a little bit more complicated on the back end of things, because you can see my file very well named here. Actually, wait, what am I looking for here? This would not show anything. It's been a while. But, I would effectively be grabbing the, how do you do this again? So, well, I guess, yeah, this would be doing it in parts. But basically, I would have to subscribe to a different input stream, one being directly from the media recorder API, and another just being from my own data that I've procured from that media recorder API. All originally coming from the media recorder API, but one, I'm either using save data or I'm using directly from the media stream or something else. But yeah, and so now what's the point of all this? Well, the point is it's just very easy to screw that up. That's really what it comes down to. And thinking back to when I actually built this, and this is really right before I started getting deep into Haskell. It was just very easy to screw something up, and then especially since it's JavaScript, it would be very challenging to track down an error. I forget how I would even do that, but it definitely took me quite a lot of time for that to happen. Whereas kind of the main pitch of reflex-dom is that it's very easy to build applications like this right the first time. And of course, the reason for that, um, a what we'll learn about with FRP and how that simplifies things in a beautiful, elegant way, but also just simply, Haskell types. Haskell types are really everything for being able to solve errors quickly. I can literally see that, oh, I gave it the wrong type. This is what was expected. And, here's what I actually gave it. And so it's just very clear, I know exactly what the problem is, and therefore, easy problem to fix. But again, very easy to even just have, let's say, for example, you know, um, this start recording button is just uh, one of many sources for events which can affect the this video thingamajig, or this video element, properly named. And you know it's just one of many cases. For example, let's say if YouTube had a to the side here some sort of like play as you go, where you can enlarge a video to the side, kind of like how this is opening up just a little bit. If it was to, let's say, open to the side in a little special element, and then allow you to continue scrolling through other videos, then um, you know we, what we would see is that we would have all of these different buttons being able to select a current video or select a video and play it as the current video on the side. Um, and so then we would have, let's see, 4, 8, uh, 12, 16. You get the idea, continuing on as we kind of scroll down. And so we'd have, let's say, 32 different elements which can affect one element or one output, right? Each of these different selections elements can determine what the video source is that's playing for that sidebar. And so with that said, with now that many different elements that can affect something, that means that much more code which can affect something. And at that point where we have imperative programming in such a complex system, I should say, it's very easy to make a mistake that is just very difficult to track down. If we have, like, here's what I mean by that. If we have, let's say, one thing, right, one output, which has been affected by some other number of outputs, right? So this event, this event here. Oh my gosh! Right, they all kind of continue to propagate up, but hopefully you get the picture. Maybe I'll move this to the side or to the middle here. But all of these, up to, let's say, 1,000 different elements can impact one element, or one value can be affected by, an infinite number of sources. So, um, you know, every single one of these sources having their own sort of chunk of code, that just becomes a lot of code to dig through for trying to find the answer. And ultimately, this is, really what we end up doing in programming. I mean, no one has ever been free from debugging. Debugging is just a natural part of programming, and especially, with the design of Haskell and the design of Reflex, what we're trying to do is minimize the amount of time that we have to think about where these errors are coming from. And so why is that? Well, because instead of our code being structured in a way, and it literally comes down to what your code looks like, which is the challenging part. But it's very easy to see how this element here affects, you know, this element or this node or this input affects this output. And the reason for that effectively comes down to the idea of subscription. So instead of writing it like this, where, we would have in our code, really what we would have is a function, call my func, and in the body of my func, we are going to update the we're going to update the document in some way. So we're going to say document dot get element by ID, some ID, and this is probably just pseudocode for sure. But just trying to kind of zoom out at a high level and talk about what are we actually doing with JavaScript. And so, if you're coming from a framework like, React, for example, and you're not used to looking at just plain vanilla JavaScript, it might be worth looking into that. I do not know. But this is effectively the core output of what we are doing, or the core effect that we are having on the output. The output being, if you can think about it as a type, as a pure type, we're outputting some sort of HTML document, which may have scripts in it and CSS binded to it. But all of that, the JavaScript, the scripts, and the CSS all revolve around the document object model, and really we use the document object model for you are going to interact with it rather by querying the DOM to find an element and then do something with it. So we might say document.getElement by ID dot some ID dot inner text equals hey. And then this could maybe do the exact same thing. Of course, if it's a different function, or I guess we're talking JavaScript, so we have impurity. It isn't impossible to have a function in here which does, change the value of the DOM to being something else like hello, hi, bonjour. So that's effectively what we're doing, and that would be just at the end of the day a lot of code to screw up. Like the honest truth again is just it's coding. You're gonna make a mistake, and it's gonna be a super simple mistake, but why would you want to spend 3 hours trying to find a simple mistake? And let me further talk about that in a second here after I finish this example, in terms of JavaScript as a language, which we are ultimately in a sense constrained to with web development. Even if you look at the internals of Reflex, what we're doing is we're effectively writing JavaScript. But more on that. So anyways, with this here, instead of writing our functions like so, we would describe the output. So instead of saying here are 5 events which may happen, and if they happen, run my function, and that will have some effect somewhere on the DOM. We have no restrictions for where that could be, and so we have to look at every single function, carefully. However, in this case, let's refer to this as some ID, right? We're going to call this our variable of some ID. So some ID is an element And we could effectively model it, again, more pseudocode, but we're talking at such a high level, sort of a system level, that if we look at the, how we would write this without actually getting into the core Haskell of writing this, but sticking to the ideas is that we would say that some ID is the result of these events which it listens to. And so it's very easy to sort of backtrack from any problems that we could run into to see um, what could result or what could cause the state to be this way. For example, the important thing about JavaScript is that, and actually this ties nicely into what we're just about to talk about with the problems with JavaScript, is that JavaScript is sort of engineered to work no matter what. It might be, a pain in the butt if, let's say, we accidentally tried to plus together a number and a string, and that caused our entire application to blow up. That would just not be great. And really, that's the stopping that from happening, or by forcing some sort of false positive. And what I mean by a false positive is, if you add, I believe if I remember correctly, in JavaScript, if you add a number and a string, I believe the result, most of the time, I'm not sure if there's an exception, but I believe the result will be that the number is coerced to a string, right? So 5 plus a, I believe, would give you 5a. And let's test this out in a second, because I do not actually have the outputs of JavaScript memorized. So just open up our console. So let's see, 5 plus a. Yes, it is 5a. And so of course, just recalling here, if this happened in Haskell, we would say, hey, could not compile the program. These two types don't fit the function of plus. In plus, we are looking for an A and an A, which are of the num type class. And so this does not work. Please revise your code. But we don't have anything like that with JavaScript. Like, the compiler is not powerful enough to be able to say, maybe it could be, but it simply chooses to give us a result no matter what, except in some edge cases that we could program into our JavaScript, which I not a expert in that sense, but yeah. And so here's the more surprising one to me is, and this is definitely a less frequent case, but if we say return 5, so if I say f plus f, oh, never mind. Okay, I kind of jumped ahead then. Okay, here's really what I'm building to anyways. If I say x plus x, what happens? I get a string, which just gives me a bit of anxiety. That even that sort of structural problem can just allow itself to happen. JavaScript says, "Yep, this is good. This seems good." And to me, my opinion is definitely that a false positive is the worst kind of bug you can run into. Speaking at a 100-foot level or 1,000-foot level, I'm sure there's definitely more, but definitely not one that you want to, not a category of bugs that you want to have possible in your code. And while it's great for not making the entire thing blow up, you might be unknowingly displaying to users something just completely ridiculous. For example, at the start of this application, based on the web browser that the user had, it was possible to, um, you know, this doesn't really fit the example. I now realize, but it was possible for the user to have a bug which only was affected by the browser that they were using. So if they were using, for example, Chrome on Windows, they were completely fine, but other cases maybe not. And it would just simply be because of the notifications system that we had. But yeah, no, that just doesn't really fit my example well because you wouldn't necessarily be able to easily stop that from happening by a type system. Although you could, in theory, build a type system around that checks the browser and returns, data browser, which, if we actually knew all the details of what was going wrong, we could have built, a foolproof browser, responsive system, I suppose. But anyways, when you use reflex, the point is that something like this is just not able to happen. And you might say, like, why would I ever do that? Like, you would never intend to do that, is the thing, right? You would never intend to have such a silly mistake like this where you're adding together x plus x. But, even consider that x plus x is 10. X plus x is a string of two functions, what is clearly to a human, reader, two functions being concatenated together as strings, which is, I don't know when we'd ever actually want that. And so, very simply, maybe in other languages, this would both result in 10. And so you have someone who's coming from another language and just simply writes this sort of bug into production, or, whatever. Maybe it's caught before production, but it's a bug, and an easy one to make. So, but yeah, anyways, the point being that this kind of issue is just not something that's going to happen through a well-typed, well-expressed system like reflex FRP in Haskell. And again, actually, I don't think I said this in this take, but reflex FRP or reflex-dom was definitely one of the main motivations for taking the plunge on learning Haskell. So yeah, and so I want to now take some time to really dive into the complexity aspect of well how how FRP can help with extremely complicated systems. Because again, this series is going to be for sure on reflex-dom and obelisk therefore, but reflex FRP and FRP in general has a lot of power for even the most complicated of systems, and I think the reason for that in a kind of simple impromptu sense is that it's just building off of the kind of ideas in lambda calculus, and applying them to a complicated sort of simulation or simplified model of how really life works. How random events in a field happen, and so, whoa, what the heck? Maybe you have no idea what I just said there. That's totally fair. But let's start with an example. And so I'm really, or wait, let me check if I have anything else that I'm missing. No, I think I've done everything in terms of imperative and JavaScript. So, anyways, let's now focus on the FRP concept in a lot more depth, by looking at how to apply FRP thinking to a more complicated system. And what could be the most complicated, or most complex, I should say, versus most complex system that we could sort of use FRP on or to think about. Um, and so I'm obsessed with the brain, and currently working towards writing a research paper on the brain, which I will not discuss here. But yeah, so in the brain, why the brain is so complex yet so simple, I say, is that the idea of a neuron or a single node, right? We have the node and document object model, browsers, HTML. We have a node with neurons. Each neuron kind of acts as a node which can propagate and affect other nodes. So it's very event based, and even further, if we think about kind of the interesting idea that our eyes are a part of the brain, um, you know, our brain is being affected by events that are happening around us, right? So, seeing someone, you know, just because it's a funny example, if we were to see an X in public, then we would likely run away from them as the event would propagate to our fear system, and we would, activate our fight or flight response. But, you know, now, anyways. So, um, in terms of how we could model the brain, um, well, we have to start by thinking about how to model a neuron. And so a neuron has this idea of an all or none action potential. So it either fires or it doesn't. So if, let's say that if a neuron receives, let me check that. You know what? I'm going to check this really quick. I forget if it's negative 70 microvolts or 70 microvolts action potential. That would cause a neuron to fire itself. Oh, okay. Oh, okay, that makes sense. So apparently, somewhere around 70 microvolts, and I believe this also it definitely depends on the neuron structure itself, but the sort of thing you would learn in your first neuroscience course about a neuron would be that it's roughly around 70 microvolts, or sorry, negative 70 microvolts for an an action potential to happen in a neuron. So, if we were to get some number of sources that actually, wait a minute, I already have this drawn out. Let me just continue on with this. So I'm kind of drawing it here in a way that all of these neurons affect this neuron, and they will produce some charge, I believe up to negative 70 microvolts, that will affect this neuron in terms of whether it fires or not. And so at the end of the day, it ends up being a sort of true or false statement on if that neuron fired. And that will result in some forward propagation of electrical potential. So now, if we think again about imperative programming, like how we have with JavaScript DOM events, then each of these neurons will have to write about how they affect other neurons. And so this definitely becomes a problem because now we're not talking about maybe a couple nodes, but we're talking about somewhere in the ballpark of 10,000 neurons potentially affecting another neuron. It could be one, but it also could be up to 10,000, if I recall correctly. And so, again, just that's going to result in a massive amount of code. And so we can also then remodel this by looking at what events this neuron, which we'll call neuron 1, subscribe to. So, you know, whether this is a true or false value here, which will allow forward propagation, is based on the output of these 5 functions in this example. Um, and so this is a a model which allows us to think about one to one, or sorry, many to one um, input to output mapping of neurons to neurons. And as complicated as the brain gets, we can still continue to expand this model in a way that accurately describes what is going on in the brain. Now could we directly talk from this model about how, I don't know, consciousness works or whatever, but maybe not. But we'd have to understand a lot more context about the brain and what neurons do what. Um, but this will allow us to understand the electrical propagation throughout the entire brain. Um, and because at the end of the day, all we have for nodes is really just neurons. And neurons, which, of course, yes, do take different forms. Some have far more connections. Some have, larger cell bodies. Some have more input. Some are, just far more developed in terms of their myelin sheath or the actual sort of conductors in the um, getting way too complicated here, but the actual um, axon of the neuron where the electricity flows out of can also be wildly different between neurons. But anyways, no matter how all those different details kind of fit into the characteristics of the neuron, and no matter how large this system can get, which we're talking billions of neurons with each possibly 10,000 connections between each neuron, but some sort of actual structure that truly makes sense in terms of how our brain works. Which I'm not sure what the last point helps with, but we can use this system to easily create code that describes how neurons work. And so it could be as simple as a line by line description of what neurons subscribe to what other neurons, right? And so, you know, um, when we create the event of neuron 1, neuron negative 1, which I'm realizing this is from an old video. I should, so 0, negative 1, negative 2, negative 3, because this is neuron 1. Um, and I'm going to change that then. Um, we can see very easily how to understand the value of neuron 1. So, if neuron 1 is really of the type Boolean, then we can understand why it was true or false. True or false, true being the neuron fired, and false being the neuron did not fire. It did not get enough electricity propagated into it to fire. And so, there's right there's even though I have this here, if I was to add a neuron checking, or, in here, which also subscribes to this one, as well as the results of this, it does not matter. It doesn't really change the structure of my code because I can still just continue to say that neuron, let's call it neuron 2, is still just the result of, or the sum of all of the electrical potentials into it. So here we have neuron 1 and I guess it'd be neuron and negative 2. If I could type. So, yeah. And really what this means at the end of the day, and it's a funny point to make, but, in terms of number of lines of our code, we would have all of the lines for creating the events, as well as what subscribes to what. And that's obviously just a high level explanation of events in this case, but you know, there are ways in which we can, act on these events. We can sort of form these events to work a certain way. For example, the easiest example is gating. So we could have an event which fires only if a certain condition is met. So, for example, if the user is not recording at the moment for our document or for our video recorder, and they click, and the event being that they click to record, then start recording, right? So if it's already recording, just throw out the event, because there's no point in doing that. Propagating the event forward, we would, as we would see from understanding the value of the output, would just cause issues. So all we need to do in that case is just throw it out. But yeah, and so I hope with the neurons example, what it's showing, and I expect everyone, or very few people here are, super knowledgeable about the brain, but I all that really needs to be understood is the idea of nodes mapping to other nodes, and the idea that this is an extremely complicated system, yet by having a very strong language or DSL to describe that system, we can make it easy to maintain that system. And so the last example I'll make, just to really drive home the idea of FRP, is a very simple one, I hope, a rock, right? So what is the displacement or position of a rock? And so how could we do that? How could we understand the position of a rock? Well, if we look over time, if we look over time, we have this massive timeline here. Rocks are like really old, right? So maybe our rock came out of a volcano and landed in I don't know, where's it? Oh, Hawaii. Yeah. And this rock was, let's say, blown by wind, and it went right into the sea. Right? Wind happened, forced it into the sea. The currents took it along. I don't know really what this diagram is, but the currents took it all the way to the shore of California. And then it's on California, and some kid picks it up and throws it. And then from that point on, there's not been much interaction. Some wind has happened, and what else did I use as an example? Oh yeah, I guess this from here. At this present point in time, wind could affect it. Any of wind or earthquakes being kicked could affect the position of the rock. And so, if we added all these events up, we would find that the position of the rock is now in, I don't know, Mexico City, having a great time. Is in Mexico City having a great time, Mr. Rock. So, living the rock and roll life. But anyways, besides bad jokes, let's continue on. Or continue on with without the bad jokes. Anyways, we could actually model this as an FRP system. And I think it's quite easy to understand. But how we would do this is we would say that rock or rock position is subscribed to the events of I suppose the wind, currents, kicking, throwing, earthquakes, and yeah. So first thing I'll say too is just to build on an unplanned build on the talk about gating. Wind and currents, the effects of these events, well, they would not necessarily definitely affect the rock. If a rock is on land and the currents are going crazy, it does not affect the rock at all. Maybe there's wind at the same time and that affects it, but the currents definitely do not affect it. And so we could say, something like gate is in water, which checks, the rock position. Again, this is just pseudocode. But gate check if the rock is in the water position. Gate check if is on land. And wind. And we could talk about that too for kicking and throwing. I mean, I guess if you want to get really technical, someone could kick it in the water. Um, Always possible, but these aren't really necessarily affected by the category of if it's in the water or if it's not in the water. Um, in terms of kicking, I guess you could also break it down in a categorical sense that it was in the region of getting kicked. Someone kicked in this area, and it was in the rock happened to be in that area. However, I think it makes more sense to just think of it as kicking is some event which talks about the rock being kicked, and so you know, if the rock was kicked, then we know that it was kicked at some velocity, resulting in a new position, right? We can think of just simply sort of the simple physics of speed, position equals time divided by speed, or no, that doesn't really make sense. But if something is kicked northeast at some velocity, then that will definitely make the rock go further. Yeah, but so anyways, the end point of this is we've modeled something really complicated and something that happens over time, right? That the key point is this is subscribed, right? Subscribed. This is kind of our pseudo subscribed operator, in that this is subscribed to all of these different events, which may or may not happen at an instance in time, right? At the end of the day, whatever logic we come down to, it's either a simple Boolean on at this current exact moment, did this event happen? And if that event happened, well, that event has some effect, right? It has some effect. So if that event happened at this current point in time, run that effect and give us the new rock position. If there are no effects or there's no subscriptions, then something would obviously just stay in position until the end of time. So, anyways, still pseudocode, and do stay put for the next videos where I actually get into how to set up Obelisk so that we can get started with Reflex, as well as how to actually do Reflex. I just, again, hopefully wanted to give a strong explanation of FRP before we dive further. Of course, if you didn't want to watch this video, you could have just skipped it, but I hope you did watch this video. And well, if you're listening to this, you're definitely listening to the video. But yeah, I think this is definitely important for understanding what we'll see with reflex-dom. I also will mention that I have a number of links in my description, which are just alternative ways to learn reflex-dom. Um, I don't think that this will be. I mean, there's a possibility for sure, but um, to say that this is definitely going to be the best way to learn reflex-dom, I think is a little silly. It could be dependent on how you learn, as well as there are a number of other amazing tutorials out there, but they're a little hidden and easy to miss. So so feel free to learn from those videos as well. It does not matter to me. This is just simply to provide a very easy way to learn reflex, a very simplified way to learn reflex. Thank you so much, and hope you enjoy the next videos. Excited.